Lesson 2 on waves, and this lesson is on interference for year 13 physics. So there are some terms that we need to know and how to define them properly. So one of them is path difference, or PD. So this is the difference in the distance traveled by two waves from different sources to reach a point, and this is usually expressed in terms of wavelength. Now, what's constructive interference? Constructive interference results in antinodes or antinodal lines because the waves arrive in phase. This happens when crests and troughs from one wave interfere with the crests and troughs from the other wave. This causes the waves with double the amplitude, and it happens when waves arrive in phase with a path difference of a whole number of wavelengths, or the path difference could be zero, and it's given by path difference is n lambda, where n could stand for 0, 1, 2, 3, and so on. Okay, the important words here are about waves arriving in phase. They form antinodes or antinodal lines, and you need to talk about path difference if you want all the credit for your answer. So as opposed to that, what is destructive interference? They result in nodal lines. When a crest interferes with a crest, what do? They cancel each other, and the path difference is an odd multiple of half wavelengths as the waves arrive antiphase or out of phase or opposite phase, and the formula is path difference is n minus half lambda. Now, when sound waves interfere, if you have two sources close to each other that's producing sound of the same frequency, then what you hear is a series of loud and soft sounds as they interfere both constructively and destructively. So interference of sound produces loud and soft sounds. If it is light, then you have bright and dark bands formed, and in order for you to have interference of light, it works best if light is monochromatic, that means single frequency, and they are coherent, and each of these have bands has what we call an ordinum.